So in this one we are going to go through some examples of vectorization thing where we're going to avoid explicit problems. So what we're going to keep in mind is wherever we can avoid for loops, we're going to avoid for loops. So we're going to go through some examples. If you see a loop, then all you have to do or try to do is replace that for loop with some built-in function. So you can import something like import numpy as np, and then you can write this equation np dot so here this formula is vectorization formula. This is input vector, this one is input vector, and this one is output vector. So that's what it looks like. So we can be consisting of a lot of dimensions. You can be consisting of a lot of dimensions, and for that normal thought comes like we are going to use a lot of for loops, but that's not what you are going to do. Like, that is one of the way that we can do things, but yeah, as we have been through the previous videos, you guys can see the difference between the for loop version and vectorized version. So that's the difference between the time that you guys will be getting that through. So what we are going to go through is we are going to implement this function in the logistic regression equation that we learned in the previous videos. So if you remember, our whole equation, so where we used to have j equals to 0, then dw1 equals to 0, then dw2 equals to 0, and then db equals to 0. So we used to do this for loop I equals to 1 to m, and we used to do zi equals to, or w transpose xi function, and plus b, then our ai thing sigmoid of zi. Then we used to do this thing. I hope you guys remember these equations. If you don't, then please go and watch the derivatives logistic regression video. In that one you will understand how this equation comes into the whole idea, the intuition behind all these things. You will get from those. So y log ai plus 1 minus y I log 1 minus a I, and that is going to, after that we are going to write the d terms. So dzi is going to look like ai minus yi, and we're going to have these things dw1 plus equals to x1i gzi and dw true. And for this normally we are going to use for loop, right? So that's what we know, x2i and gzi. But in vectorization we are going to use something different for these. So we are going to replace gzi, we're going to replace these things. Normally we are going to write for loop for these things, right? So we are not going to write for loop for these things, and we are going to replace these things with only a function that will be named as a gw equals to np dot zeros, and in that we are going to have this thing n minus x comma 1. So all the values of gw1 to gw whatever number that is n or whatever that number is, those will be stored in this thing, and that's how we are going to like get rid of one for loop, and that will make our code much efficient. So that was really matters. So we are going to eliminate the second loop, and in the loop we're going to write something like gw plus equals xi gzi. So this thing is going to go in here in the improved version of our code. So I hope this thing is clear, guys. So now you might be thinking, yeah, this thing can be made simpler, I mean more efficient and more powerful, and we can do much better in logistic regression and gradient descent using this vectorization thing, rather than doing only this thing. But I'm hoping the concept is clear, and we're going to explore this concept too deeper in the next one. So until then, keep grinding and see you in the next one. Bye.